here we're told that f prime of x equals 6 minus x, and f of 5 equals negative 7, and we're asked to find f of 2. Again, when we're given a function's values at two different points, and we're also given the derivative, that makes us automatically think, well, we're probably going to use the fundamental theorem of calculus. To remind us, the fundamental theorem of calculus tells us that the integral, the definite integral between 2 points of a function, f of x dx, will equal the antiderivative at b minus the antiderivative at a, the lower bound. We can rewrite this in another way, because remember, this relationship is that capital F prime is lowercase f, the function. And so I'm going to rewrite it just because I like to see it in a different way, which is the integral of a to b of f prime of x dx equals f of b minus f of a, all lowercase. This is something we're used to seeing and will apply more to the question that we're looking at. So how does this work? Let me start writing this in yellow. Let's fill in the blanks. A and b, where did those come from? Well, that has to be our lower and upper bound. Those are based on the x values, so I see here we have 2 and 5. So I'm going to rewrite this as the integral from 2 to 5 of f prime, and f prime is 6 minus x dx, will be equal to f of 5, because we see that's our upper bound, minus f of 2, because we see that's our lower bound. And so we're given these values for some of them, and so we can plug in. I know f of 5 is negative 7, and so I'm going to replace f of 5 with negative 7. The integral from 2 to 5 of 6 minus x dx equals negative 7 minus f of 2. And our goal is to figure out what f of 2 is going to be. And so what I can do is I can rearrange this. I'm going to add f of 2 to both sides and subtract the integral from both sides. So we're going to get f of 2 equals negative 7 minus the integral from 2 to 5 of 6 minus x dx. And now our goal is to solve for 6 minus x, the integral, from 2 to 5 of 6 minus x dx. So we get f of 2 equals negative 7 minus the integral, or actually, let's evaluate it. The integral of 6 will just be 6x, minus the integral of x is x squared over 2. And we're evaluating this from 2 to 5. Alright, we're going to keep going. Negative 7 minus, the first one is going to be 6 times 5 minus 5 squared over 2 minus, I'm going to scooch this over just a little bit, 6 times 2 minus 2 squared over 2. Alrighty. And so, we're going to simplify this, equals negative 7 minus 30 minus 25 over 2 minus 12 minus 4 over 2, which will just be 2. Negative 7 minus 25 over 2, that is 12.5, so 30 minus, or actually, I can do 60 over 2 minus 25 over 2 minus 10. This will equal negative 7 minus 60 minus 25 is 35, so we get 35 over 2 minus 20 over 2. I'm converting that 10. This will equal negative 7 minus 35 minus 20 is 15, so we get 15 over 2. So we want, in the end, negative 14 over 2 minus 15 over 2. So we get our answer is negative 29 over 2. So we find that f of 2, and this is how we want to write our final answer, equals this. f of 2 equals negative 29 over 2. And sorry for the little delay on my writing. Again, we found this answer by finding and applying the fundamental theorem of calculus.